All right. This is my elevator pitch. I'm Isaac Baucher, a sophomore too. A little bit about me. I'm the team leader for the 2024 Pensacola Trebuchet team at the University of West Florida. The Trebuchet team, what we're all about is we're trying to make a medieval style trebuchet with a 150-yard range, a 250-pound projectile, which we decided quite recently that we want to make an ice ball, which is going to be like a giant ball of ice. And our goal is to make it be able to reload about once per minute with adjustable aiming. And the main way we're probably going to adjust aim is with the release hook, which is right here. And the weight of the counterweight. And the way we came about that is we split into 4 sub-teams to divide and conquer the building of each individual thing. So we had each team come up with their own sort of design method or design tool for each of their parts. So the 4 parts are the ballistics team, which their main goal was to calculate the height and range of the trajectory. And here we have one of their graphs that they came up with. And our structure team, which created a CAD model to hold up everything. And so ballistics, they built a Python script to calculate necessary release velocities in order to reach a predetermined range with air resistance and initial height parameters, while the structure team built a CAD model to perform force analysis on the predetermined load and with a safety factor of 4 to ensure that nothing breaks. So here's their CAD model, and they performed force analysis on it, and this was the graph that they came up with. And then we had the beam team, who did force analysis on a beam in CAD, and the release mechanism team. And so the beam team constructed a CAD model performed force analysis on the beam with the desired beam length to determine the necessary material, which they decided was steel, because we were kind of in between steel and wood for it. And the release mechanism team, they researched previously built release mechanism designs for trebuchets, and they came up with their own design that would be able to adjust the release angle of the trebuchet. And so you can see these fingers, this one will have a higher release angle, this one have the highest, and this would be a sharper, kind of lower release angle. Here are some of our finances. We estimate the total cost of the full-scale model, and that doesn't include, as you'll see, our little scale model that we made. And some of the bigger purchases we have is the steel I-beam, which is about $1,400, the pivot beam, which is $250, 2-part epoxy resin, which we need to make the mold for ice balls, which will be about $200, and the base structure material, so all the wood and all the nuts and bolts, will total up to about $500, we estimate. And we have some more information about finances. So we got an amazing grant from the University of West Florida Home Markets College of Science and Engineering for about $1,000. And the Office of Undergraduate Research funding we applied to recently, and if they give us the total amount that we asked for, we would get about $3,000. And we also started up a GoFundMe. So we're hoping that will cover the last little $1,000 that we might need for the full-scale model. And using all of our design tools, we created a little 1-to-scale prototype that we brought to the Maker Faire. Thank you so much. Thank you.